Hello everybody. In this video we're going to start with the simulation environment. But before we go there, we're almost done now with most of the features that are going to be of interest to most of the users. And we will move to the simulation environment now. But before we go, we just need to understand the difference between the two environments. Here in the properties environment, I define the main components of the system. By this, I mean the components, the materials that I'm gonna use in the system, as we did here, and the thermodynamic model, which are the two main inputs. And we were able to see that we can do some analysis, which is very useful and helpful in many applications. But in the simulation environment is the place where we're gonna do the actual simulation, and that's why any of us should expect that the interface is different. So in here you would see that we have like this palette here, and we have the layout is different because of the different function of this environment. So here we enter streams, we enter blocks, and we define the streams and define the blocks and put all the inputs that we need to put so that we can run the simulation. And in this video, I'm gonna be just going through the interface, just to make the users familiar with this interface. So you would see that this is where we do all the simulation. This is the layout, which is the place where we put the streams, we put the blocks, and put everything. The ribbons would be kind of different somehow. There are some kind of common things like this point of the unit. You would find the ribbon that is related to economic studies, to dynamics, to the method of calculations. Is it going to be sequential? Is it going to be equation oriented or mixed mode? This is something that we discussed in the previous or in the very first one or two videos, something like this. Um, I'm not gonna go through all of this now because it's something that will take time, and it's better to discuss in its place. When we need something, we will go to its place. But just want to make you familiar with the ribbons. Um, and Here you'd find in the navigation bar that the folders here are different. You have some like setup that what we it's similar to the one in the properties environment. You can choose the unit sets. You can choose if you're working steady state or a dynamic mode. The stream classes, which is something that we discussed in defining the streams or the components in the beginning. You're gonna be using mass or mole as the basis of your inputs. The ambient pressure and the valid phases, it's liquid, vapor, or liquid only, or vapor only, whatever. Um, you can go to these calculation options. There are a lot of information here, or a lot of options here. Again, this is something that we can discuss in its place later. Um, some of them might be kind of intuitive, like you know that is it gonna do heat balance calculations beside the mass balance or not, if it's gonna calculate the component molecular weight from the atomic formula, or you can define it by yourself. Something here like use results from previous conversion paths, and this needs kind of clarification because let's say you put the inputs and define the streams, define the blocks, and put the inputs, and you want to run the file, so it's gonna run and generate the results. In case you edit or change any of the inputs that you put in the stream or in the flow sheet, and you want to redo the iterations, or you redo the simulation, um, is it gonna start from the previous results as the initial values to start the simulation, or it's gonna start all over again from the very beginning and discard all these results that you got? Anyways, so there are a lot of things here that you can check by yourself. Um, There's something that related to flash conversions. If you have any flashing units or flash calculations, how the calculations will be done, the temperature limits, the pressure limits, the number of iterations that's going to be done. Anyway, so this is something that you can check by yourself. Um, for stream classes, again, this is the type of streams that you're gonna use. If it's solid, if it's mixed stream, if it's again, this is something that we're gonna use in its place. It needs more of discussion, so it's not the right time to talk about here. Um, Anyways, so this is the part of it. If you have anything related to solids and the particle size distribution, then you can do it here. This is the default particle size distribution. If you have any, you can define more particle size distributions if you want. Um, Anyways, there are some more folders here about the stream prices that are related to economics. Again, the unit sets we discussed before, the custom units. If you want to define any new units for any physical quantity, you can do it here. The property sets is exactly the property sets that we discussed before. You can add more here. Um, uh, and the property sets that you define in the properties environment will show up here in the simulation environment. There are and I'm just interested in going into the main parts. There is this folder that is related to analysis. If you do any analysis to streams and which is similar to the analysis that we did before, it's gonna show up here. The flow sheet is it's an important part of the navigation bar. This is where you can see all the inputs that you put. You can break the flow sheet into sections, and each section consists of a number of blocks. It's sometimes useful in some cases. Here in the streams and in the blocks, these are two very important parts. This is where all the streams and all the blocks show up. Of course, nothing is here because I don't have any streams defined or any blocks defined. Um, Here you can define the utilities, cooling water, steam, or natural gas, whatever the utility that you want. If you have any reactions, you can define them here. Again, this is something that we will discuss later. We have here the analysis tools and flow sheeting options. You can use them to do something like sensitivity analysis, like optimization, stuff like that. And this is where the results would show up, which is the results summary. Um, so in this video, I'm not interested in all these things. I just want to go into the first thing that you do is defining streams. So if I have a stream defined, I have here, oh, we didn't talk about the palette. So the palette is a very important part of the simulation environment, and this is where all the units and the streams are found. So if you want to define something like a stream or a block or a unit, they are all here. You can find them put in categories like mixers and splitters. You can find separators like flash drums and like simple separators. If you put the mouse over one of these, it's gonna give you a hint. So it's two outlet component separators, and that's very useful actually. It lets you know what's the purpose of the or what this unit does. It's like heaters, heat exchangers, like columns, distillation columns here, many types, reactors, like many types of reactors, the pressure changers, you find pipes, pipelines, valves, and compressors, pumps. Some manipulators here. It's gonna be discussed later. For the solid, you have all the units related to solid separation or solid operations like crystallization, crushing, screening, solid washing and drying, fluidized bed, solid separation like cyclones, scrubbers, whatever. So we have a lot of other units here that should cover all the types of operations that we do in chemical processes. Um, and here in the left, you'd see that it gives you a material stream. So if I put the mouse here, it's not going to give any hint. But this is the material stream. You can put a heat stream or a work stream based on what you want. So let's say I'm going to define a material stream. And to define stream, all this was quick. Let's start over again. All what I do, I press on this stream, and please pay attention to what I'm gonna say here because it is it's very simple, but it makes a lot of causes a lot of confusion to people who are not familiar with it. In the normal mode, I'm now the mouse has its arrow shape, which is the normal shape of the mouse. If I want to define a stream, I'll click on the material button, and now the mouse looks different. And as you see, it takes the cross shape or the plus sign shape, and I click anywhere on the flow sheet, and you'd see that it puts the start of the stream. And it's waiting for me to define where the end of the stream will be. So if I put it here, so the stream is defined, and now I'm done with adding stream to the flow sheet. But if you notice the mouse still have the shape of the plus button or plus sign, which means that it is still in the mode of adding streams. So defining a stream or defining the inputs of the stream requires double clicking on it. If I double click, it's not gonna go into the stream, but it's gonna define one new stream. Again, this is because I am in the mode of adding streams. It's something that I find students do a lot in the tutorials and the exams. They want to get out of this mode to be able to go into the stream and define it. And each time they click on the stream, they define one more stream. So it's kind of going into an infinite loop of defining more and more streams. To get out of the adding stream mode, this is pretty simple. Either click on this button, which is the cancel insert mode, or press the escape button on the keyboard. Both will do the same thing. I don't need this anymore, and I don't need this anymore. And if you see here, you would notice the stream S2 is showing up here, and each stream you define here will show up here when you put it on the flow sheet. To define the stream, you can either go here into this folder and go to input, or double click. And you see it already took you into the input part of the stream. To define a stream, you need to define three things, three pieces or four pieces of information. I'm sorry. The four pieces of information is the temperature, or let's make it the flow rate, the composition, and one of three things, either pressure or temperature, or two of the pressure, temperature, and vapor fraction. So the flow rate, the compositions, and one of temperature, pressure, and vapor fraction. That's why it gives you the option here. If you choose here the vapor fraction, you need to define either the temperature and pressure. So it's one of the three. Usually people use the temperature and pressure to define the stream, so I put any temperature, 20, and the pressure of 1 bar. You can change the units, it's here in bar. You can choose it to be atmosphere, inch water, kilogram per meter, per square centimeter, whatever the unit that you want to use, it's gonna be there. Um, so this is how you define the pressure. The flow basis is gonna be mass or mole. We chose the default in the very beginning when we did the setup here. We went to the specifications, and we chose it to be mass. So that's why it is the default here to be mass. Um, and the stream is not yet defined. I need to define the flow rate. I put it like 100 kilograms per hour. Here you can put the mass flow or mole flow. You can put it mass fraction, mole fraction, whatever. I'm gonna put mass fractions now, and put any fractions. The fraction has to be from 0 to 1. However, it accepts any number. For instance, if I put 10, 50, 60, it's gonna accept these, even if the sum is not equal to the sum that you defined here. And what it does actually is that it normalizes the values. So it gets the sum and divides all these values by the sum. So it gets the fraction of each one of them. If you don't define this, then it's okay for it. It's gonna consider this as the total, the sum of, or the 120 would be the mass flow of the stream, and it's gonna calculate the mass fractions from the mass flows as you would expect. So this is all for or the basics of defining streams. We will go into more details in the next video, inshallah. So see you then. Goodbye.